Welcome back, everybody. Today we are going to learn about our next special triangle. It is called a 30, 60, 90 triangle. You'll see on the screen here I have an equilateral triangle drawn. This is going to help us find our 30, 60, 90 triangle. Remember, for an equilateral triangle, all sides must be the same length. So we'll start with the x's actually. Now, in order to create our 30, 60, 90 triangle, I'm going to drop a perpendicular bisector down my triangle. So that would split this up into 1/2 x and 1/2 x. In order to prevent using fractions, I'm actually going to make each of these sides 2x, which means that each of these halves would be x. Now, looking at this triangle that I created here, you'll notice I've created two 30, 60, 90 triangles. One on the left, one on the right. Now, I know this bottom side, the side across from the 30-degree angle, is x. I see that the hypotenuse is 2x. Now, I want to find what is the length of the side across from the 60-degree angle in terms of x. So what I will do is use Pythagorean theorem. So I know that y squared plus x squared must be equal to 2x squared. I want to solve this in terms of x, and I'm trying to solve for y. So I'm trying to get y by itself. That's my goal here. Let's first simplify this right side. 2x squared, we have to square the 2 and square the x. Now let's move this x squared to the right side by subtracting x squared on both sides. So 4x squared minus 1x squared, that's 3x squared. In order to get y by itself, I know I need to square root both sides. Remember, like yesterday, normally I would do plus or minus. However, y is a length of a side, so I know that it has to be positive. Again, just like yesterday, I can split this up into two separate radicals. And I know that the square root of x squared is just x. Now finally I will rearrange it. I know that this side, the leg of the right triangle, has to be equal to x times the square root of 3. So if I know x, I can find all my sides here. Let's write this out neatly. So flip to the next page. The 30, 60, 90 triangle theorem looks like this. So just like what we did yesterday with our 45, 45, 90 triangle, I want you to label all the sides first, find the value of s, then find the variables that you're looking for. If you want to write those steps here, there's plenty of space for you to do so. Let me show you how this will work in an actual problem. So the first step, label each of your sides. So the hypotenuse is always 2s. The side across from the 30-degree angle, in other words, it's the side that does not create the 30-degree angle. So notice that these two sides create the 30-degree angle. The side that is not used to create the 30-degree angle is this side here. So this side has to be equal to s. Similarly, these two sides create my 60-degree angle. The side that's not used is this over here, the one that has a length of 15. Therefore, I know that this side has to be s square root of 3. Now I'm going to look at these and see which one of these could I solve. I could solve this one. It has an actual number instead of a variable. So I'm going to write out this equation. I have s square root of 3 equals 15. S is being multiplied by the square root of 3. So in order to get s by itself, I must divide by the square root of 3 on both sides. Now I know x is going to be equal to s, so I'll go ahead and rationalize this by multiplying by a sneaky 1. My sneaky 1 in this case is square root 3 over square root 3. It's the same in the numerator and denominator. That's why it's called a sneaky 1. It's equal to 1. 15 times square root 3 is 15 square root 3. Radical 3 times radical 3 is radical 9, but I know the square root of 9 is just 3. Remember, your last step, you always want to check if this can reduce. 15 and 3 have a common factor of 3. So I could reduce that to 5 square root of 3. Now that I have my value of s, I can find x and y. So I'll plug in s here. I know x is just equal to s, so I get 5 square root of 3. Y, however, is equal to 2 times s. When I'm multiplying this by 2, I can multiply the 5 and the 2 together to get 10 radical 3. Pause the video and try the 3 practice problems below. Here's the answer for the first one. Here are the second two. All right, here's what I want you to work on today. Here's your reflection. In this figure below, square ABCD is attached to triangle ADE as shown. So we have this is a square, and we have triangle ADE. It's attached at segment AD. If the measure of angle EAD is 30 degrees, and AE equals 4 square root of 3, then what is the area of square ABCD? That's all I have for you guys today. Tomorrow we will begin working on our trig functions. See you then.